Hi, time for the math easy solution. We're going to discuss the limit of a function. I showed before what limits were. You can see that video, but now we're going to apply to functions, and I'll show you what I mean. Let's say if we have a graph like this. I'll draw it here. I'll show you why. Let's say if we just have a random graph like this is f of x. This is y. This is x. The limits are important in calculus in general. So now let's say if we have, so we want to know the limit. Basically, so limits are basically as you get closer to, let's say, a, what is this value? So basically, as we get closer and closer, we don't actually have to touch it. And this is the limit would be the same thing. Let's say, so we would write it like this: limit, or a limit of f of x as x approaches a would equal to L. So this is called L for limit. And this definition is very useful because we don't actually have to put a inside. So it's just close to a. So x doesn't really equal to a. It's just really close. Really close to a. And this would apply to this is the same thing if we were to have, let's say, a graph like this. If this was the same graph, and this was, let's say, but this was a circle. So this is not defined here. So this is the same thing, or even if you had, or at a it equals this. So let's say this is f of a yeah. So f of a is different from what this was. So if it's somewhere up here, the limit is still the same. This is still limit. Limit still exists, and it's the value that it should have been if it was linear, if it was continuous. Like, okay, so that's basically what limits. That's the definition of a limit of a function, and we'll show you through an example what I mean by this. Let's say if we were to get, let's say if we want to get limit as x approaches 1 of x minus 1 divided by x squared minus 1. So now here's a problem here. If we put x as 1, we'll get 1 minus 1 over 1 squared minus 1. This is just 0 over 0. Since we have it divided by 0, this is not defined. So we can't just put it in here. So now, but this actually does have a limit. So we want to find out what this limit is. So we'll just put in closer value. We'll use the calculator right now. We'll just go, let's make a table. We'll go x, then this would be x minus x squared minus 1. So let's look at from the left side. This is, we need to check both sides. It might be, because you might have something like this or whatnot, or you might even have something like, you might have a function like this, where one of so you might have a function like this. So you have to check both sides. So for here, we'll look at x is greater than 1. So let's say if we put 2 in here, let's so 2 we'll have 2 minus 1, 4 minus 1. So that's basically 1 over 3. So now if we put in, let's say this is go really close to 1.1. We'll put in a calculator. Okay, so we'll just drag this in here. So let's put in basically drag 1.1 minus 1 over divided by 1.1 squared minus 1. What does this equal? Yeah, so basically that equals 0.476. So we'll just write that here, 0.476. So if we were to put in, let's get even closer to it, put another 0 inside, another 0. So we'll get 0.4975. Yeah, so we're getting closer to actually 0.5. We were to put, let's say, a couple more zeros, 0.2 zeros, 1, 2. So now here, yeah, we get 0.4999. So it's getting closer and closer to 0.5, and then this would be, this is 0.499. What else? 975. So as you can see, yeah, if we keep going, it's getting closer to 1, so to 0.5. So basically, we'll actually see that the limit is 0.5, but since we have to check for both sides, so let's say if we were to check for x is less than 1. So if we were to go from the left side instead of the right, we'll get, let's drag this down here. So if we want to search from, let's say, 0.9, what do we get? So if we put 0.9 in here, .9. So this one we get 0.52. So we'll write 0.5. And if we put let's get closer to put another 9. This is 0.50, 0.5025. If we put another 9 and another 9, so we'll get even closer. So it's getting closer and closer to 0.5. So this is, let's go 0.999. We'll get 0.50. What was it? 225. It keeps going on. So basically, again, it's closer to 0.5, and the limit is actually 0.5. So the limit here, as x approaches 1, is basically x over 1 over. This equals 0.5, and I'll show you the graph of this. If you were to graph this, let's just remove this with x, and how this graph looks like. So basically this is how the graph looks like, except here, I don't know why Google, it doesn't have the undefined values. So at this point, actually, if you were to graph it, it would be something like this. So this is how it should have been. It'd be something like, so this is how it should have been. This is f of x. This is basically x minus 1 or x squared. So this is how it should be. So although this is undefined here, the limit still exists. So because as you go closer from both sides, you get this. So now I'm going to show another video actually, without having to put in a calculator, because this one you might be wrong in some ways, because you don't really know when to stop running this limit. Because if you have something like, let's say, if you have cosine of 5x over 10,000, and you want to get the limit, let's say limit as x approaches 0 here. If you were to put this in a calculator, so you would go, let's say, cosine 5, let's go point times 0.1 divided by basically 10,000. This equals 0.877750. So it looks like it's going to 0, but actually, as if you were to go really close to 0, this actually, you actually get a value here. You actually go to, the limit actually becomes something really small. So the limit, if we call this f of x, it's easier to write, f of x. So the limit would actually be 1 over 10,000. That's because basically cosine 0 is 1. But sometimes it arises that if you calculate it, it looks really small, because so it's not equal to, the limit is not 0. As if you put in a calculator, you may have been confused. But this is basically limits of functions. I'll show you a foolproof way later, and then also using something besides just putting a calculator, and how to get the limits. Well, thanks for watching, and stay tuned for another math easy solution.